There are two basic types of tie rod ends, spring-loaded and preloaded. To check the preloaded unit, which has no internal clearances inside the unit, you should raise the vehicle's steer wheels free from the ground. With the vehicle's weight off the steer wheels, move the tire wheel assembly from side to side. As the wheel assembly is moved by this rocking action, note any excessive movement in the tie rod end. If the ball and socket is worn, there will be a noticeable movement in the tie rod assembly. On a spring-loaded unit, one test is to compress the spring. Spring-loaded sockets should have a firm spring pressure when compressed all the way. To check these types of joints, use a large pair of channel lock pliers, which are also known as multi-grip type pliers, and place one jaw under the base of the ball joint and the other on top of the end of the joint. By squeezing the handles of the pliers, you should be able to see the movement inside the joint. If the movement exceeds the maximum allowable, which is specified by the manufacturer, you should report it to your supervisor. Some manufacturers add a wear indicator to their ball joints. The most common type of wear indicator has a shoulder that sticks out of the bottom of the joint by about 50 thousandths or 1/16th of an inch or 1.27 millimeters when new. Other manufacturers provide a specification for the maximum amount of movement that is permissible. You should consult the vehicle manufacturer's manual for this tolerance and for the correct procedure for checking it. In the case of a torsion bar or a long arm, short arm type suspension, where the spring is acting on the lower arm, you can test ball joints by having the vehicle raised off the ground slightly and supported under the lower arms. This places the weight of the vehicle on the ball joints. Now place a lever under the tire and pull the tire assembly up. Take note of any movement in the ball joint. Inspect the rubber boot on the tie rod end for any signs of being torn or damaged. If torn or dislodged from its seat, dirt or abrasives may have entered the tie rod end, accelerating wear in the unit. If the steering system is a parallelogram type, move the tire wheel assembly from side to side and check the idler arm bush for excess movement. Alternatively, push and pull on the idler arm at the same time, checking movement in all of the pivoting points attached to the steering linkage. Check that the rack housing is securely mounted to the crossmember, and check the tightness of these mounting bolts. Inspect the rubber bellows for any signs of being torn or damaged. If torn or dislodged from its seat, dirt or abrasives may have entered the unit, accelerating wear. With the vehicle raised, have your assistant rock the steering wheel from side to side. Squeeze the bellows so that you make contact with the inner ball joint and feel for any excess movement to check for wear in the inner ball joint attached to the rack. You will need to repeat this procedure for the other side. Check for wear in the steering shaft universal joints. Rotate the steering wheel from lock to lock and ensure these universal joints rotate smoothly. A steering system of the parallelogram type is normally fitted with a steering box assembly. You should check for excessive movement in the steering box itself. This can be done by having the vehicle on the ground and feeling the free play in the steering wheel with the road wheels in the straight-ahead position, while watching the wheels to see how much you can move the steering wheel before the road wheels start to move. Check this amount of movement and report any excessive movement to your supervisor. Inspect both the steel lines and the flexible hoses for any signs of deterioration. Check the steel lines for signs of chafing. If present, chafing is usually a sign of loose or missing locating clamps. Either can necessitate the replacement of the lines if rubbed through. Check the fittings for tightness. Check the flexible hoses for cracks, wear, and hardening.